Dr.M.G.R. Educational and Research Institute, University, Mother of all, Chennai. Dr.M.G.R. Educational and Research Institute, University, Mother of all, Chennai.
Good afternoon to everyone connected here. Welcome to the national level webinar on scaling the IoT with edge computing, blockchain, and Industry 4.0. Let us start this session with a quote. If you think that the internet has changed your life, think again. The Internet of Things is about to change it all over again. A quote from Braden O'Brien. I would like to extend my warm welcome to the chief guest of today's event, Dr. S. Neduncheliyan, Professor and Dean, School of Computing, Bharath Institute of Higher Education and Research, Chennai, and to all the academicians, faculty members, research scholars, and students of various other institutions across the globe. Today, we have with us on studio Dr. A.R. Arunachalam, Deputy Dean Academics Phase 2, HOD, Department of Computer Science, Phase 2 campus of Dr.M.G.R. Educational and Research Institute, Chennai. I am Dr. R. Kavita, Assistant Professor, Department of Computer Science, Dr.M.G.R. Educational and Research Institute will be hosting today's event. Today, we are going to learn and see how to scale effectively the IoT devices with the help of edge computing that brings computation and data storage closer to the location where it is needed, and also by blockchain technology that can be described as a data structure that holds transactional records while ensuring security, transparency, and decentralization. Our speaker of today will give more insight to the topic. Now, I would like to invite Dr. A.R. Arunachalam, Deputy Dean Academics Phase 2, HOD, Department of Computer Science Phase 2 of Dr.M.G.R. Educational Research Institute, Chennai, to welcome the gathering.
Yeah, so thank you, ma'am. So on behalf of Department of Computer Science, Dr.M.G.R. Educational Research Institute, Adayalampattu Phase 2 campus. So I would like to invite you all for another event today, which is national level webinar on scaling the IoT with edge computing, blockchain, and Industry 4.0. So first of all, I would like to thank our Honorable President Engineer A.C. Arun Kumar sir for approving today's event, as well as for his enormous support towards conducting a lot of online events during this period. So next, I would like to welcome all the other dignitaries, starting with the Vice Chancellor, Pro Vice Chancellor, Rector, Provost, Register, Joint Register, Deans, Faculty members, HODs, students to this national level webinar today. Next, I would like to welcome the speaker of today's session, Dr. S. Neduncheliyan, who is a professor and dean at School of Computing, Bharath Institute of Higher Education and Research, Chennai. So thank you so much, sir, for spending your valuable time with us. Really, I mean, I think today's session is definitely going to be an interesting session. So thank you so much for accepting our invitation to take this wonderful session today. As you all know, I think IoT is now playing an important role in the technology arena. So where it has been able, I mean, IoT is now playing an important role in various kinds of applications, no? Whether it is healthcare or whether it is agriculture. So it is, I mean, the IoT devices are now able to monitor and as well as the control the mechanical, electrical, and electronic components. So now I think today's session is now going to be how the IoT is going to be scaled with other things like edge computing, blockchain, and as well as the Industry 4.0. So definitely this session is going to be a valuable session. So I really welcome all the participants to this webinar, and I really appreciate them for showing interest towards all these kind of online sessions. So on behalf of Dr.M.G.R. Educational Research Institute, I once again welcome all the participants as well as the speaker for today's session to this webinar. So have a great session and have a great day too. And once again, I congratulate the faculty members, Dr. R. Kavita, Ms. L. Darni, and who are taking care of this today's event, as well as Mr. Ganesh Babu, who's taking care of the technical support today. So I wish this event all the best and success. Thank you all.
Thank you, sir. It gives me immense pleasure to introduce our chief guest, Dr. S. Neduncheliyan, Professor and Dean School of Computing, Bharath Institute of Higher Education Research, Chennai. Professor Dr. S. Neduncheliyan completed his bachelor degree in computer science and engineering in 1989 from University of Madras. He did his Master of Science in AI Robotics from School of Electrical and Electronics Engineering from University of Saints, Malaysia in 1999, and he completed his PhD in Information and Communication Engineering from Anna University in 2009. He is having more than 30 years of teaching experience in abroad and as well as in India. He has published more than 102 research papers in various international and national journals and conferences. He has supervised more than 54 ME and 10 PhD theses. He has organized 27 webinars and invited as a resource person for 12 webinars. He is a recipient of Indira Gandhi Excellent Award in 2013 from International Business Council, New Delhi, Outstanding Educator and Scholar Award in 2014 from NFED Coimbatore, Best Research Supervisor Award in 2015 from GRABS Educational Charitable Trust, Best NSS Unit Award in 2017 from Anna University, South Indian Achiever Award in 2020 from Kalam Dream Trust, Lifetime Achievement Award in 2020 from Bestow Edutrex International. He is having fellowship from IETE and membership from IET. His main research area includes wireless sensor network, robotics, Internet of Things, and wireless communication. We welcome you, sir. Before we march into the session, we have a note for the participants. We have short question and answer session at the end of this event. You can post your queries in the comment section. Regarding the feedback form will be available in our YouTube description box from 4 p.m. to 6 p.m. Indian Standard Time today, and later the link will be deactivated. I repeat, the feedback form will be activated from 4 p.m. to 6 p.m. today, and later the link will be deactivated. And regarding the certificates, it will reach you by a maximum of 3 days. Without any further delay, may I request Professor Dr. S. Neduncheliyan to please take over the session and enrich us with his knowledge. Over to you, sir.
Okay. Good afternoon. Let me open the slides. Is it visible?
Yes, sir. Yes, sir, it's visible.
Oh, okay, good. Thank you. Okay, once again, I would like to thank Dr. Arunachalam, Deputy Dean of Dr.M.G.R.Educational and Research Institute, and management and all faculty members for giving me opportunity to share my knowledge with faculties as well as the students. Today's seminar title is on scaling the IoT with edge computing, blockchain, and Industry 4.0. Actually, we are entering in a new era of computing technologies, that is the Internet of Things. So IoT is a sort of universal global neural network, in the cloud which connects various things. So the IoT is intelligently connected devices and systems which consist of smart machines interacting and communicating with the other machines, even environments, objects, and infrastructures, and the radio frequency identification that's called RFID and sensor network technologies. So this technology will rise to meet the new challenges. So as a result, enormous amount of data are being generated, stored, and the data is being processed in transferring of the information can be much easier and less costly through the internet. So in this webinar, I'm going to focus on scaling on IoT with edge computing, blockchain, and Industry 4.0. So my discussion is, my outline of the discussions are background of Internet of Things, how IoT works, current state of the future of the IoT, potential and challenge of IoT, IoT with the blockchain technology, IoT with the edge computing technology, and Industrial 4.0 technology, and industrial application of IoT. Let me give you the background of Internet of Things. Okay, well, actually, the Internet of Things it was not officially named till 1999. So how it became IoT? First example of IoT is from early 1980s. So what happened? Actually, one of the university, Carnegie Mellon University, the local programmers, they would connect by the internet to the refrigerator appliance. If you go to any universities, for example, there will be a lot of department in separate far away. For example, if you go to the IIT and all, you can see computer science department is located far away from the other EEE department, such a way that all the departments are located far away. So what happened? The research people or programmers, if they want to have drinks like cool drinks or whatever, so what happened? Initially, there was only one refrigerator which is located in one building. So, for example, other building people, they want to have cool water. So they have to go far away. They have to walk from one department to other department, then have a drink. Because before making a trip, they don't know whether water is available or not, whether that water is cool or hot. They don't know anything about it. So they have to walk. So check to see if there was a drink available. Even if it is available, if it was a cold or not. So for that case, what happened? They have designed and developed the Coca-Cola, refrigerator. So they design then to avoid the problem before make a trip to that particular department. They have to make sure whether it's water available or if it is cool or not. Make sure about it. Then they made a move and had the waters. So this is the first internet. This is actually first example of Internet of Things is from the early 1980s. So they have taken prototype model as a Coca-Cola machine. So how IoT works? So we are going to focus on components of IoT, structure of IoT, and functioning of IoT. Okay, well, so you know already what is IoT. Everybody knows physical objects are not limited devices. Actually, all are connected together in one separate network and exchange the information. So it will be like a machine to machine or world size web or internet to everything. So that's IoE is discovered by the Cisco systems. Well, there is IoT data lifecycle. So it has capture, communicate, analysis, and act. Even we can say collect, communicate, analysis, and act. What does mean collect? Collect, for example, we used to deploy the sensors in any environment. Okay, the sensor is the edge node. That is the sensor is the edge node mobile device. So that is supposed to collect the information from the environment. Okay, for example, if I want to just check the temperature, so there will be a temperature sensor. That sensor is supposed to collect the information about the environmental temperature. Okay, so device with the observing capabilities can record a physical phenomenon. So the device is supposed to collect the information, capture the information from the environment. That is the role of the sensor. Okay, that is the first cycle. Second one, communicate. Once if you collect the information, that information is supposed to communicate with the microcontroller or any devices. So that's what telecommunication technologies are present to link IoT devices and other IoT devices or the central servers. Okay, so it's communicated with the microcontroller where the analysis process takes place. So it's responsible for analyzing the data that comes from the IoT devices. So based on the analysis report, based on the result, it's supposed to do the perform the specific action. So IoT lifecycle contains capture, communicate, analysis, and act. Well, so this is a IoT generic architecture stack. There are 4 layers. So perception layer, network layer, IoT platform layer, and application or business layers. So each layer having, the perception layer is the same level like a physical layer. So you all are familiar with what is the role of physical layer. It's actually equivalent to physical layer. It's equivalent to, it's corresponding to the TCP/IP protocol model. So what is the purpose of perception layer? Perception layer is that to capture the data. What I said, capture the data from each IoT devices. So IoT devices is nothing but machine which is connected with the internet. That is called the IoT device. Okay, so next will be a communicate. So we need network layer. Network layer, the role of network layer sends the data from the IoT devices to the upper layer. That is through it can be 2G or 3G, how you can say that 5G, okay, through Wi-Fi, Zigbee, Bluetooth. Okay, this is a communication channel. So radio frequency and RFID technology. So it corresponds with the communication stage. And IoT platform layer, where analysis take part. You can store and analyze the data coming from your IoT devices. And the final one is your application business layer. So where the action takes place. So it used to particular IoT applications. And also it's the smart scenario called the smart home, smart agricultural, smart mobility, smart health. Everywhere is applicable. So it's include the apps, reports, flowchart, everything. It comes under the action. So finally, the layer has the ability to act following the IoT life cycles. Okay, there are the 4 fundamental components of the Internet of Things. Sensors, device. It comes under the, it's sensor devices, IoT devices that should be connected with the gateway. That gate, from the gateway, it goes to the cloud or server that the user who can receive. So for example, here the user who wants to check the temperature, the end user, but the IoT cell phone is out of the IoT device. So the one who wants to check the temperature in USA or temperature in Singapore or wherever else, so who can request the information to the particular the sensors through the gateways. Then, so the sensor is supposed to collect the gather the information, temperature, environmental temperature, and transmit through the gateways. Then it goes to the cloud. From there, the user who can receive it's a visible. So similar connectivity. So here we can use so many sensors, pressure sensor, temperature sensor. So here the gateway is a bridge between the devices are from internet devices to the gateway device. Your internet, your cell phone to the gateways. It's act between these two devices. So this is a structure, IoT structure from the from the data from the node. The things is nothing but your node. Edge will be collect the information and communicate with the gateways. From there, you can just send through transfer through the internet. This is the application of given here. Okay, well, of the IoT, the global connection growth is mainly driven by the IoT devices here. That means the both consumer side is as well as the enterprises is the side. Totally global networks of in the IoT devices are now 7 billion devices are now connected with the internet through what you call smartphone, smart home, and connected car, connected health, smart retail, smart supply chain, smart farming, then industrial internet, smart grid. So everywhere is all the devices are connected. More than 7 billion devices are connected in the internet. Well, so what is the future? Future of what? Where the IoT is used? Actually, the world first factory. This is the first cellular IoT based smart factory is the Nancy. Nancy located Ericsson Panda. So here they are using. It's the IoT technology improves the efficiency and results combining cellular IoT, and also they are using for optimize the manufacturing process. So let me clearly explain about what does mean optimizing manufacturing. Let me explain clearly about in Industrial 4.0 and transforming the future of agriculture. So here the BA Intelligence survey expects that adoption of IoT devices in the agricultural industries will reach 75 million in 2021. That should be growing 70% annually. So the IoT smart farming solution is the system. It is used for monitoring the crop field. And also we can use the light sensor, humidity sensor, temperature sensor, soil moisture sensor, then crop health sensor. So they are using different types of sensors to just monitor the paddy field. Not only paddy field, any cultivation field. And the next one is the empowering a smart societies. According to the Gartner forecast, about 20%, that means 1.39 billion of IoT units shipped into the smart city application by 2021. So that will be utilized for the sustainability and climate changes use cases, especially in transportation and smart building also. By 2025, it is estimated that there will be more than 21 billion of IoT devices. This is just some quick survey that in 2016, there were more than 4.7 billion things connected to the internet. See, this is according to the IoT analytics. But fast forward to 2021, the market has been increased to nearly 11.6 billion IoT devices. You see the difference within 5 years. It has changed from 4.7 billion things to 11.6 billion IoT devices. And also it is used for the cyber criminal. In 2016, the world was introduced to the first Internet of Things malware. That's called malware. Comes from the cyber criminals. And also, most cities will be now smart city. You heard about the word is of smart cities. Yeah, consumer won't be the only one using IoT devices. So the smart cities are the one who can just travel without any traffic. So remote manage, collect the data through the things. Okay, let us see the potential of IoT. Number one, improved performance. When we just what are the potential when we use the IoT? Number one is improved performance, because IoT helps you to monitor the productivity process and analyze the mistakes. So we used to say that Industry 4.0, because we come to know when raw material entered into the industry, from raw material to productivity, products, raw material to actual products, where it goes, it travels in each and every department and finally converted to the product, right products. So the system, the IoT-based system is going to monitor the product in each and every stage. Even sometimes the employee used to come late, that should be noted by the system. Sometimes during the break time or even sometime during working time, it is easy to track the employees. Then we can track the available materials, whether it's available or not. There are so many things. So really the IoT helps you to monitor the productivity. And we should have some target. We're supposed to manufacture the product within the 2 months, within the 1 month, like that. Due to some problem, it may not happen. Excuse me. So in this case, IoT really helps to make more productivity and avoid the mistakes. And second one, creative services. It gives customer insight due to the close service monitoring. Close service monitoring, especially nowadays, that pandemic period, patients they suffer a lot to go to the hospital and for the treatment and all. So what happened? IoT-based system, especially health monitoring system like health monitoring systems, the doctor who can just monitor the patient and check the temperature, patient temperature, and give the prescription remotely. That is possible. So it gives more services, create the more services. Drone. So we used to see in the TV news and all, drone used for the people those who are surrounding. I mean, moving around there and all. It's also comes under the IoT technology. Reduce the cost, reduce the equipment downtime by up to 50%, and reduce the equipment capital investment. The percentage will be 3 to 5, extending the useful life of machinery. Even in revenue, I mean government departments and all, there are different IoT marketplace can be divided into 3 categories like government IoT, industrial IoT, and customer IoT. All are used to generate the revenue for the government. Okay, let us see now the trends of IoT in 2021. So IoT in blockchain technology, then edge computing technology, then industrial technology, industry 4.0. Yeah. So what is the blockchain? Actually, it's actually called a distributed database. It has some records, list of records. So each and every record is called the blocks. So we used to say that it's an open distributed ledger. You heard about the word ledger. So what is the use of the ledger? That can record the transaction between parties. And also, blockchain is used for secured by designing from the tampering and revision. And also, we can just offer a decentralized identity management. So this is actually the blockchain consists of 2 types of the elements. One is called the transaction, another one is the blocks. So there are 3 diagrams here: centralized, decentralized, and distributed. So here transactions is a sense that here the action created by the user in the system. For example, the person A who wants to transform, do the transaction, money transaction to B. So that here they have to use the blocks. Each block is a given record of valid transaction in the correct sequence, whether it goes correct or wrong. Okay, let me give you an example how a blockchain works, especially in money transaction from one person to other person. From right person, whether it goes to right person, sender and receiver. So those in the network approve their transactions valid. So all are given, given the approval. So in this case, once they given approval, the block then can be added to the chain, which provides the indelible and transparent records of the transaction. Now the B who can receive the money from the A. So the key characteristics of blockchain should be decentralized, because if it is centralized means it will help the intruders to exploit the things easily. So if we make it as a decentralized, so we can give the protection for the security for the particular transaction. So decentralized is a no controlling power or point of failure. And also permanent or fixed. So ledgers, they are maintaining the ledgers can't be changed without any network agree to it, because there are more than 5, 2 or 3, 4, 5 persons are involved to just give the approval. More parties are involved to give the approval, and facilitates trustless transaction. Of course, unchangeable ledger. That means transaction can be made unknown parties with the minimum of risk. And another characteristics of the blockchain is the distributed processing power, because here we have keep it like a decentralized nature. It means the network shares the load easily. Then how about the advantage of blockchain? Increase the trust. So we can just transaction our money to the right person. So there will be no intruder involved. And also removes the need for controlling power. Better security. It's a better security because we have decentralized the process. But complete record of all transactions, because each and everyone we are maintaining a lot of blocks. Okay, then let us move to the edge computing now. What does mean edge? Like a telecommunication. Let us take the telecommunications. So it may be a cell phone or cell tower. It's an edge. So let us take an example of automotive sector. It could be a car. So let us take the example of manufacturing sector. It could be a machine. So let us take the information technology. Laptop is an edge. So these are called the edges. So here what we can do that here, a device which produces the data is edge devices. Cell phone, yeah, you can use and send the information. Okay, so send the information and produce data in edge devices like a machine or sensors, any devices through which information is collected and delivered. That's called edge devices. So the device which is connected with the internet. So edge gateways. Gateways is a buffer where edge computing processing is done. And fat client. So it's a software that processes data in edge devices. So it's opposite to the thin client. And edge computing equipments. What are the equipments available? Which nothing but devices are like sensors, machine can be outfitted to work with edge computing. So mobile edge computing, we used to say that MEC. It's a growth of edge computing in telecommunication systems like 5G scenarios. Okay, well, so here let me explain what is the use of what is the role of the edge computing. So, okay, in client-server technology, let me take the example of client-server technology. There will be a lot of clients. Those clients are connected with the internet. So, through the server, okay. So, client who can request the server to do the process. So, server who can, after process, server who can respond to the client. That means the result processing, and after processing, send back the results. So, for example, the client is located in, client is located very far away from the server, maybe 1,000 kilometers or 1,000 kilometers away from the client or server. You just think about it. It will take a lot of time to send and receive the information. So, in case there will be a problem, like especially a latency problem will occur. You know, latency, time taken to reach the destination, time taken to send the information to the destination. That's a latency. Okay, it will take more latency, and also it will take much amount. It is very possible. It is not possible to save the money, because when we move the edge computing nearer to the source, it is possible. That's what a part of the distributed computing topology in which information processing is located closer to the edge, where things and people produce or consume the information. So now, for example, let us take the paddy field cultivation process. So one of my friend, let me tell you that one of my friend who is monitoring his paddy field from the USA. Is it possible? Of course, it's possible. For example, he wants to check it out whether there is a water in the paddy field or not. It is possible. Okay, then it is possible to pass the water to the paddy field. It is possible because there is no need, manpower is not necessary. There will be sensors in the paddy field. We can deploy the sensors in the paddy field. That sensors collect the what do you call that soil moisture. So we can use the soil moisture sensor. The moisture level sensors just collect the level of the moisture in the soil. So we can fix a threshold, whether 10, if it is reached at 10 means your moisture level is high. So no need to pass the water. If it is less than that, maybe 2, 3 means then you have to pass the water, means the sand will be dry. So this is a system. So we can write the program and in the microcontroller, then we can test it. So if the level is decreased, that sensor collect the information from the environment and transmit to the microcontroller. So what is the role of the microcontroller here? Microcontroller switch on the water. So automatically water will pass to the paddy field where actually requires. So now he can control away from that particular place. So it will take some problem, like there will be a more latency, and also is cost will be very high. So here what happened here? Let us move the particular edge computing closer to the sources where the data collected. Okay, once the data collected, they send the information to the edge computing where processing happen. Once it's processed, then give back the feedback. Result to the edge node. So sending information. So that's what say does not suffer latency issues when we implement the edge computing. And also companies can save money by having the processing done locally. And third one, reducing the amount of data because that needs to be processed in the centralized or cloud-based location. Cloud is located very far away. So the information, amount of data is supposed to travel from client to the cloud, then come back again after process, how to back again. So we can reduce. So when we move the edge computing near to the source where data collected, let us move the edge computing device near to the sensor. It's very possible. So we can avoid the high latency, make it low latency, reduce the latencies. So that is the purpose they have just implemented this kind of technology. Okay, this is the edge cloud computing complementary. So you can see that factories there, thermal power station, human smart gadget, and smart cars, offices. So what happened here, for example, thermal power or car, just any devices, these are called the end devices, end device. So factory is supposed to send the information to the cloud through the cloud, cloud. In this case, the data is supposed to travel from factory to the edge cloud, come back again. So there will be a more latency. So when we move the edge server near to the factory, edge server near to the office, edge server near to the smart car, okay, well, so let us see how edge computing works. So the edge local processing is, edge gateways just move to the Internet of Things already. Okay, so edge computing allows data from Internet of Things edges to be analyzed at the edge of the networks before being sent to the data center or cloud. That is the concept of edge computing technology. And what are the beneficiaries of enabling edge computing of the Internet of Things? Number one, lesser network load. Of course, because device Internet of things are located very far away. The things want to send the information. IoT device, the device is supposed to send the information to the cloud. It takes more network load, require more network load. So when we implement enabling edge computing, there will be a lesser network load. Next, zero latency. I told you already, zero latency. Reduce the latency and reduce the data explosion and computational efficient. Computational efficient. So the device who wants to do the process, what happened here? The process, the data is supposed to travel to the transmit to the cloud where processing takes place, then come back. So this is a computation. But when we move the edge computing nearer to the Internet things, it's easy. And also cost at autonomous operations and security and privacy. So there is we can't allow the intruder to exploit the information. So make it security and privacy. Right. This is actually taxonomy of IoT based edge computing. So there are network technology. This is actually particularly considers some features like wireless networks technologies and computing nodes and computing paradigms, service levels objectives, major enablers, and data types, application, and attributes. So what does mean network technology here? The IoT device can communicate with the edge computing platforms through either wireless network technology. So we know already through the Wi-Fi, 3G, 4G, and 5G and all. Okay, or wired technology. So in wired technology, you need you need Ethernet. Okay, so these network technologies vary in terms of data rates, transmission range, and the number of supported devices. So wireless networks provide flexibility and mobility to user who executes their applications on the edge server. So however, wireless networks technologies are not as reliable as wired technologies. So here the computing nodes, next will be computing nodes. There are servers, base station, routers, and vehicles. So here the computing nodes includes these all routers and vehicles that can provide the resources and various services to IoT devices. What is the use of these devices? Okay, then computing paradigms. Computing paradigms, the various computing paradigms are used in IoT to provide the different services that's depending on diverse application requirements. So these paradigms can be categorized into cloud computing, edge computing, and mobile edge computing, then Hadoop cloud computing, and hybrid platforms. So the cloud computing, cloud computing is the centralized computing. Edge computing is the decentralized computing. So cloud computing is centralized computing infrastructure that aims to provide interruption-free access to powerful cloud server. So these servers can rapidly process large amounts of data. So upon receipt from the remote of IoT devices and send back to the users. It's happening. By contrast, what happened here, edge computing is a decentralized computing platform that brings cloud computing capabilities near IoT devices. That is the network edge. So an important types of edge computing platform is the MEC, mobile edge computing, which brings cloud computing capabilities to the edge of the cellular network. So here, computational and storage service in MECs are provided at their base station. So unlike MEC, the fork computing, you heard about the fork computing. The fork computing employs a local fork nodes. See, in the local fork nodes are nothing but local network devices such as a router and switch. These are available within the limited geographic region to provide their computational services. And there is one more computing paradigm is here, cloudlet. Cloudlet is another form of edge computing, in which delay sensitive and computations intensive tasks from IoT devices are performed on a server deployed. And the third one is cost, next is service level objectives, latency minimization, the network management. So cost optimization is a deployment of an optimal number of nodes at appropriate position can significantly reduce the capital. And also optimal arrangements of edge nodes can minimize the operation cost. Then how about the energy management? So according to the study, I have studied that here 1 trillion IoT nodes need sensing platforms. So it really supports various applications using power harvesting to ensure the scalability. Of course, it will reduce the cost also and avoid the frequent battery replacement. The resource management. So resource management includes coordination of the resources. What are the resources? And estimation of available resources. And also proper allocation of workload. And next is data management. The large number of IoT devices are present or expected to generate large amount of data. Of course, it generates lots because we have deployed a lot of sensors or IoT devices that should be generate the data. That is a large amount of data that need to be managed in timely manner. So we have to focus on data management. So we need the efficient and effective data management mechanisms are desirable in edge computing. And major enablers. Next one is the major networking technologies, software development kits and resource rich network elements and virtualization here. So the driving forces behind the success of the edge computing are different types of the technologies. So these communication technology are used in the edge computing for device to device, device to edge server communication, and also software development kits with the appropriate application program interfaces that should be assisted in the developing and integrating in new compatible applications and then data types. So these data types can be broadly categorized based on the delay sensitive, and also hard real-time data cannot tolerate any delay at a time. So whereas here soft real-time data can afford the several bounded delays. So these delay tolerant application can be classified as the non-real-time applications. And attributes are low latency, proximity should be proximity, and location awareness, dense geographical distribution, and network context awareness. Then IoT in Industry 4.0. You can see the revolution in Industry 1. Start from 1.0 to 4.0. In Industry 1.0 in 1784, started from mechanization steam power, weaving loom. It's the first Industry 1.0. You can see that in 1870, it converted into a mass production using the industry, like mass production assembly line and electrical energies, use the electrical energies. And when we moved to the 1969, Industry 3.0, the industry became automation. They have used the computers and electronics devices for the manufacturing purpose. They have used the robotics to do the pick and place operation. The machine is automatically, the robot supposed to do the pick the object and place it. And today, the Industry 4.0, cipher physical systems, Internet of Things, they use Internet of Things. So what is the Industry 4.0? Actually, this is a transforming using new age digital technologies. So here, in manufacturing, it is primarily about the gathering plus analysis of the data across the machines, and plus business systems, plus remote plan operation and management. So what is the use when we go for the Industry 4.0? What is the purpose? What is the use? We can reduce the cost, and also the result is here, make it faster and flexible, reliable, and also efficient processes. And here, of course, here that how to achieve. And data collection, we supposed to use the sensors, gateways, routers, and media converters are used. So they just collect the data using these components, and data analysis using the platform like use artificial intelligence or machine learning algorithms and techniques, and cloud where the process will be take place, and the data presentation, storage, cloud computing, and visualization process takes place here, and control. Yeah, actuators for control, process improvement, and the remote operations takes place here, remote access management. And this is actual digital manufacturing aspects. You can see that from how they are converting from raw materials to the product. There are so many steps involved here. So there are so many sensors are used to just follow the raw material, whether it is raw material, then where it goes. There are the different sections are there. Operators, management, logistics, and data scientists. They are supposed to monitor the things, where it goes, and what is the stage of the product now, whether it goes to the control unit or quality control unit, whether it's converted. So the system itself monitor the each and every process of the product, and also just communicate with the cloud servers. So beneficiary of digital manufacturing is a cost saving. So predictive maintenance for breakdown avoidance, anything, energy optimization through the monitoring and control, and improve the equipment life. It's possible. And also we can enhance the productivity when we just implement IoT in Industry 4.0. Should be improved. So employee focus on more creative work while machines focus on other level tasks. And also we can reduce the go-to-market time. Go-to-market time, it means that the system is supposed to check whether material is available, raw material is available in the industry itself. If it is available, okay, so that raw material is supposed to send it to the other department. If it is not available, the system itself inform to the vendor to just bring the raw material to the industry. So there is no manpower. Manpower is not needed the particular process. And also the happier customers, enhanced quality assurance, good traceabilities, so we can easily just track the product. At the same time, the employee, programming of quality parameters, business, of course, product innovation, and the business cycle predictability, then sourcing and procurement, and also business continuity. These are the advantages when we go for the Industry 4.0. Okay, let us move to the application of IoT. So IoT is used in so many industries, like so many areas like agricultural, civil, mechanical, automobile, and healthcare. This is a scope in agriculture, like there should be a high precision crop control when we implement the technology like IoT. So using data such humidity, temperature, soil nutrient appropriate crops can be selected, and data collection from the external can become very efficient with the proper data handling. automation. I told you already that control, water control. So it can be using automation. And the basic water is there. So here we have fixed already the pH value is here 14. That means range goes from 0 to 14. pH of less than 7 that indicate that acidity. If it is pH of greater than 7 means it's the base. So we can check it out. Check it out whether what is the value of potential of the hydrogen using that particular. That should be traversed through, sent to the base station, that the base to cloud, we can store it. Okay. In implementation in agricultural. So irrigation automation, this is one of the process. So we can deploy the sensors, implanted sensors in the agricultural field. Then the wall, solenoid wall. So based on the sensors instruction, whether that the soil level is the high, moisture level is high or low. If it is the moisture level high, then whether switch on, and other low means switch off, like that, whatever. So based on the irrigation automation, it comes under the irrigation automation process. Then what about the fertigation? Fertigation thing, but irrigation and fertilization. Usually what we'll do, if you want to do the fertilization process, in manual process, already, the man will go to that area, then just put the urea, whatever, then come back. So now what we can do that, we can mix the fertilization along with the water and pass the water to the field. Okay. Here, what is the advantage? Plants will be healthy, and 42 to 50% water will be saved, and 25% to 30% nutrient saved. So that is called the fertigation and crop maturity. And other one is there is one more project like the autonomous robot. They have designed. It's a combined project. Israel and Europe collaboration project. They have designed and developed the autonomous robot. So what is the role of your robot is it has to move in each and every plant and check the fruit, whether the fruit is the right fruit or not. If it is the right fruit, then pick the takes. If it is not right, so it may move to the other plant. So such a way that it has to go. The robot supposed to move from one plant to other plant. So it has to one plant to other plant and just pick the fruit. So check and pick the fruit. So here what happened here? It takes 25 seconds to pick the single fruit. So the example, if we appoint the people, manpower, okay, people who just apply the people to just do the process, they will maximum time 8 hours to do the process. In 8 hours, they will take lunchtime and break and whatever. But when we implement the robot, it takes 25 seconds to pick the single fruit, and also it can work 20 hours per day. So agri-robot market will reach $75 billion by 2025. And also here, market leakage. Cotton, sugarcane, where it is available, then what is the estimation of this period, everything will come to know through the IoT technologies. Price forecast also. Next is this is how IoT is changing the construction site. So more detailed plans, healthy of bridges, design of new ideas. So let's see productivity. In productivity in civil, so for example, if you want to construct the building or bridge, whatever, so we have to, the contractor who's supposed to, the engineer who's supposed to fix the deadline and the targets. In case if it is not possible to complete the process within the deadlines, the result in the budget will be increased. This is a major problem. So how to avoid this kind of problem? Let us go to the IoT technology. IoT can enable more readiness and efficiency that should be used, that should be improved the productivity. Because here we can reduce the manual work. That means less manual work. And also to improve the project delivery and customer satisfaction when we implement the IoT technology in construction site. And also adequate supply to materials to ensure the smoothness of the project. I told you this supply material is available or not. If it is not available, what happened? So we have to call up the person to call up the vendor, ask them to bring it. So how about the process? It will delay. Sometimes if the material is available, they'll bring it. Otherwise, it will take 2 days, 3 days, 5 days. Then deadline and target budget will be increased. So in this case, when the materials are going to over, then the system itself identify the materials available and dial up the vendor, ask them to bring it before the material over. This is one of the, you can improve the productivity. And however, so late supply of materials often occurs at the site due to the poor scheduling caused by the human error. Next, maintenance. So, power and fuel consumption, the result, both are very important. That will result in wastage if not actively managed. That will impact of the overall cost of the project. So in this case, sensors help to prevent the problems and also keep the customers as happy. Safety and security. So if anything happen, especially theft and safety and all, it's really useful. There will be a camera there. The camera will just identify the peoples, those who are roaming around there and all. So that should be monitored by the people, those who are residing far away remotely. This is so IoT technology will not only prevent staff from being exposed to the dangerous conditions, but can also detect those conditions before they happen. Waste management is, you heard about the waste disposal pins. Here you can nowadays what happened actually, the waste management system in the municipality or corporation people, they used to go to each and every state, collect the wastes, okay, collect the waste from the disposal pins. So what happened here? If there is a full or half or even there is no waste materials, they used to go there and see that, for example, in street 135, 3 streets buckets are filled. So what they are doing is, in the system, they used to go to every street and check whether filled or not. If it is filled, then collect it. Otherwise, go to the next street like that. So when we implement the IoT-based waste management system, so that we can fix the sensors inside the bucket, that sensor itself inform that whether filled or not. Okay, so now street number 1, 3, 4 buckets are filled. So now what happened? The people will come and collect, go to the street number 1, 3, 5, then go back. So they can save the energy, they can save the traffic, avoid the traffic, save the money and everything. So IoT is also used in structural health monitoring, detect the vibration cracks also in the civil structures. And IoT design to, this is one of the project, it's a real-time monitoring by using the set of sensors. So sensors can be fixed in the engine side, like engine as well as the tires. So the sensor is supposed to check the flow sensors, temperature sensor, pressure sensor, all are fixed in the engine. At the same time, ultrasonic sensors, temperature sensor, and pressure sensor are fixed in the tires. So the system monitor the tire as well as the engine through the sensor networks, and motorcycle, even car, even heavy truck. So just if anything happen, so microcontroller is connected to the microcontroller. The vehicles are monitored to observe the changes occurred in the system to analyze the critical failure factors. So here the problem is, with the help of the microcontroller, serial monitoring and data from Arduino boards, so collect the information. So the failure will be predicted earlier. That is the purpose of this particular project. This was one of the students who did. And implementation in automotive technologies, the fleet management, one of the examples is the Olo taxi monitoring. We can monitor what time it will reach to our place. Then weight measurement is possible, location tracking and several other sensors also. Again, then fleet operator can easily go through this information. And also automotive maintenance systems can predict analytics is one of the most selling feature of IoT. And autonomous vehicles, there is IoT technology, connected cars from, according to an estimation of Gartner, there will be more than 250 million connected cars in the world by the end of this 2020. And in-vehicle informatics, telecommunication, telematics, and in healthcare application, I told you already, remote patient monitoring systems, the doctor who can monitor the patient remotely, no need to go to the hospital, patient who no need to go to the hospital, even doctor no need to go to the patient home due to the pandemic period. So we can easily monitor the patient's temperature, pressure, or whatever, the one who can easily monitor from remotely. And depression monitoring, it's a possible, there will be an app. That app daily assessments were found to correspond with the more in-depth and objective cognition test. It's a possible through the IoT devices. And tracking staff and inventory, tracking staff. So the system can track the staff members and the medical inventories throughout the building. And what are the advantages of implementing the IoT in medical side? Reduce the cost, better patient and experience, reduce the errors, and improve the disease management. Okay, thank you.
Thank you so much, sir. I must mention this session was impressive and gave an insight of scaling IoT devices. I hope this session has opened the nuances of research and publication in everyone's mind. Now to the question and answer session. Let me read out the questions for you, sir. Is blockchain technology a secure one since it is decentralized? Blockchain technology is a secure one.
Yeah, it's a secure one because it's decentralized. So there are parties are giving approval, and so there is not possible to allow the intruder to exploit the information.
Okay, sir. Next question. Edge computing only process and analyze partial set of information. Is it advisable to use edge computing in medical field?
Yeah, of course, it's really useful for the medical field because the data, the patient's patient data travels from one place to other place, even if it is far away. It's there will be a huge amount of data transferring. So due to the bandwidth problem, network problem, it's very difficult to when you reach the doctor. If it is complete data, okay, no problem. He can just give the prescription for get the data, whatever get the data from the patient. If it is not full data or something happened due to the network problems, then he can't predict the medicine for the patients. So when we move the edge detector, edge computing near to the device, it's easy for the doctor to give the prescription, right prescription.
Okay, thank you, sir. May I now request the technical team to please display the appreciation certificate as a token of our love and affection. Thank you, team. May I now request Ms. L. Dharani, Assistant Professor, Department of Computer Science, Dr.M.G.R.Educational Research Institute, to deliver the vote of thanks.
To everyone connected here, it is my pleasure to propose the vote of thanks for this national webinar on scaling the IoT with edge computing, blockchain, and Industry 4.0. First, I would like to extend my gratitude towards our Honorable President, Engineer ACS Arun Kumar, for accepting our request to conduct this webinar in a grand manner. I am also grateful to our Vice Chancellor, Dr. S. Geeta Lakshmi, our Provost, Dr. G. Gopalakrishnan, our rector Dr. D. Vishwanathan, and our registrar Dr. C.B. Palanivelu for their tremendous guidance and motivation. A special thanks to Dr. Malini Pandey, Joint Register HNDS, Dr. S. Ramalingam, Joint Register Phase 2, Dr. S. Manivannan, Dean Phase 2, Professor K. Sendil Kumar, Deputy Dean Admin Phase 2 for being the pillars of support. I would like to thank our HOD cum Deputy Dean Academic Phase 2, Dr. A.R. Arunachalam, for his constant encouragement, and Dr. R. Kavita, Assistant Professor, Computer Science Department, for coordinating this event successfully. I also thank Mr. Ganesh Babu, our System Administrator, for providing the technical support. I would like to thank our beloved speaker, Dr. S. Neduncheliyan, Professor and Dean School of Computing, Bharath Institute of Higher Education and Research, Chennai, wholeheartedly for accepting our invitation at such a short notice and deciding to support us even during this crisis. It was a really knowledgeable and an enriching session. I would like to say a big thank you to the faculty members and all other participants for joining us from all over the world. We are excited to see the enthusiasm you all have shown. Keep supporting us by connecting to all our future programs. Stay home, stay safe. Thank you.
Thank you, ma'am. For the participants, please do not forget to fill up the feedback form. The certificate will reach you by a maximum of 3 days. You will definitely receive the e-certificates when you fill up the feedback form. I see in the comment section asking for the presentation. We have it in our policy that the speaker's presentation is not shared, but this video is visible in our YouTube channel. The name of our YouTube channel is Dr.M.G.R. University Phase 2 Digital Learning. This video can be viewed from our channel. It is available throughout, and also please do not forget to subscribe our channel. Thank you so much participants for your support and love. Until next time, stay safe, stay healthy. Thank you.